Today I'll be presenting ELVIS, Enhanced Lowlight for Video Instance Segmentation in the Dark, a paper accepted to CVPR 2026. Here is the summary of the following topics we'll cover in this presentation. So here's a little introduction. Video instance segmentation in low-light videos is highly challenging due to the degradations such as noise and blur. Existing VIS methods struggled in such conditions due to the lack of large-scale annotated data and limited synthetic pipelines with realistic temporal degradations. We propose ELVIS, Enhanced Lowlight for Video Instance Segmentation in the Dark, the first framework that enables domain adaptation of state-of-the-art VIS methods to low-light scenarios. Our contributions are a new synthetic low-light video pipeline which incorporates illumination adjustment, noise and blur, adding an enhancement decoder head into existing architectures to disentangle degradations from content features, and an unsupervised network VDP net which estimates degradation profiles for a calibration-free synthesis of realistic low-light videos. So here's the diagram of the overall pipeline. Here is our low-light degradation model, which can synthesize illumination, blur and noise given an input phi. The VDP net, a unsupervised network that can estimate phi to recreate the degradation from real low-light videos onto the synthetic videos, and the overall ELVIS framework, which synthesizes these low-light videos on the fly for training, and incorporates an enhancement decoder head for a regularization loss. So we'll very quickly go through the degradation model. We have illumination adjustment, which we first convert the sRGB images into XYZ color space and then apply a linear transformation. Blur degradation, which we synthesize camera shake motion blur using a multivariate Gaussian kernel. Physics-based noise, which we use common noises such as read noise, shot noise, quantization noise, and banding noise. And overall, at the bottom, you will get this equation, which is our degradation model, and phi is a vector of parameters that are used to synthesize for each degradation. So here's some quantitative results. The rows that are highlighted include the enhancement decoder head, whilst the rows that are not highlighted are only fine-tuned on the synthetic low-light videos. And with this table we evaluate on the synthetic YouTube VIS validation set. And you can see that including the enhancement decoder head, our performances are better than simply only fine-tuning on the low-light videos. And you can see that this is the case for both the ResNet backbones and the transformer backbones. We also evaluate on real low-light videos. So you can see that on both the ELVIS S dataset and the ELMO S dataset, on the left we compare against synthetic low-light pipelines, and you can see that ours shows the best performances. And on the right we compare against two-stage baselines, which is you apply a you apply an enhancement method as a pre-processing step, and then you apply a pre-trained VIS method, and you can see that ours still performs better than the two-stage baselines. And here's some qualitative results. You can see that ours is effective at using the enhancement decoder head. We're effective at tracking the woman across the video, and we don't have these false detections. And comparing against two-stage baselines, you can see that ours does not segment the building and consider it as part of the truck. However, we do like to note that ours is not able to segment the truck whatsoever. However, compared to the other one, that A-stable LLV, which is the closest at segmenting only the truck, we also don't have these false detections, false positives. So, in conclusion, we propose ELVIS, the first domain adaptation framework to improve video instance segmentation in the dark. ELVIS provides the following: an unsupervised synthetic video-specific pipeline, a degradation profile estimation network VDP net for calibration-free synthesis, and the addition of an enhancement decoder head into networks to disentangle degradation features from the underlying content. We show that implementing ELVIS into existing state-of-the-art methods can easily boost low-light VIS performances. And we identified the release of properly annotated low-light VIS benchmarks as critical future work for the community. This work was supported by the UKRI My World Strength in Places program, the EPSRC, doctoral training partnerships, and the University of Bristol. Here are some links if you would like more information. Thank you.